A boat has a mass of 6,800 kilograms. Its engine generates a drive force of 4,100 newtons due west, while the wind exerts a force of 800 newtons due east, and the water exerts a resistive force of 1,200 newtons due east. What are the magnitude and direction of the boat's acceleration? We are asked to find A. So, step 1 is our picture. We have a boat. It's going to be a square. And it's going west. Which way is west? Never eat sour waffles. It's going this way. It's going this way with a force, which I'm going to call Fe for engine. This is the force the engine is providing. I don't know how to say it. And I'm going to start my step 2 right here too. Step 2 is known. I'm going to say that Fe is 6,800. Oh, oops, sorry, that was the mass. Our Fe is 4,100 newtons. Now, before I continue, I want to make sure I know which direction I'm going to set as positive. Usually, up and right has been the positive, but since this problem, we seem to be going west to the left, let's make that our positive. Switch it up. This is going to be our positive. It can be either. If you just make sure you put in the correct signs, it doesn't matter which way you set as positive, you should get the same answer. But we're going to set left as positive for now. And we have another force, the wind. Exerts a force of 800 newtons. I'm going to change color for that one to green. No. And it's going east, so the other way, right? This is going to be the force of the wind, Fw. Fw is 800, but we want to be careful. It's going right, and if left is positive, right is going to be negative 800 newtons. And we have a third force of water. Oh, water should have been blue. Okay. And it's a resistive force of 1,200 due east. Same direction as the water. Oh man, water and wind. We got two W's. I'll just say water. Okay, which was negative 1,200 newtons. We also know that the mass of this boat, we have a mass, is 6,800 kilograms. And we're asked to find the acceleration of our boat. So we're going this way, right? And I assume we have an acceleration. We want to find out what this is. So step 3 is going to be our equation. So now this is our first time using this equation, or at least like in the order that I'm recording these videos. It is Newton's second law, I believe. It states that the net force acting on an object equals to the mass and acceleration. I think it's easier to understand when using it in problems, so let's just do that. So the net force, we have 3 forces in our problem, right? These are our 3 forces. It's net, so we're adding them all. I'm going to rewrite it here again. Our net forces is Fe for the engine plus F wind plus F water equals to the mass of the boat and the acceleration of the boat. We are asked to find acceleration, so I'm just going to go ahead and divide both sides by m and flip it so it looks pretty. And now I'm going to put in my numbers. The force of the engine was 4,100 plus the force of the wind was negative 800 plus the force of the water was negative 1200 over the mass is 6,800. Put that in your calculator. And I mean, you could, distribute the negative sign right now if you like. 4,100 minus 800 minus 1200 over 6,800. You can do that if you want to. And it should be 0.31 meters per second squared because this is our acceleration. This is a positive number, right? It's positive, which tells us that we actually are going left. There's a chance that we might get a negative here, and then maybe we were actually going this way. But in this case, we were going west. West was our positive, so that is the beginning of using F equals ma.